Here's example 7 for circles. This will be our last one for this particular assignment. Again, this will correspond to assignment number 23, circles. There's a couple of oddities on this one. Similar to the previous two, we have an equation here, and the point would be we need to manipulate that equation to be center radius, which again is written right above it. This needs to look like this. All right, now one difference in this example would be the fact that the x squared and the y squared both have that 4 in front of them. And we don't need those coefficients there. These need to be a 1x squared and a 1y squared. So if you have a situation like this, and I believe there's a homework question comparable, you would hopefully go, all right, those 4's that we wish to get rid of are both multipliers. And so how about we first of all divide both sides of this equation by 4 to get rid of those multipliers. So over here, 0 divided by 4 remains 0. And what we are effectively doing is we're distributing that division by 4 to every single term over here on the left-hand side of the equation. Let's go through and divide every term in the equation by 4. So that would give us 1x squared. 56 divided by 4 is 14. That would be 14x. All right. And then, of course, that just becomes a 1y squared, 4 divided by 4. And 124 divided by 4 is 31. Okay, so there we go. Get rid of that coefficient. This is the first example where we've had that issue. All right, what do we do from there? Now it's starting to resemble what we've seen on the previous examples. One thing I would throw out is we need to subtract the constant to the other side. So let's move that 31 out of the way and subtract it over. All right, now we're going to start to separate out our terms that have x. And so we've got x squared plus 14x. Leave a gap in order to complete the square, right? Okay, now, and we'll do that in a minute. And I want to remind you again that the reference to complete the square is that little formula that the smart math people figured out. All right, one other thing that's different about this question is that the y squared is the only term that contains the variable y. Y doesn't have a middle term. We won't need to complete the square when it comes to the variable y here. It doesn't have a middle term. That's the only y term in the equation. So, complete the square for x. Middle coefficient is 14. So again, our beautiful formula that smart math people figured out, 14 over 2 parentheses squared. 14 divided by 2 is 7. You do what's in the parentheses first, right? So 7 squared would be 49. So we'll add a 49 over here. Let's see, if we add 49 to the left side, what do we need to remember to do? Add 49 to the right side. Good idea. Good job, you guys. So there we go. So now, this would be 18 over here. And I hope that trinomial will factor. It should. Smart math people figured out what needs to be done to make sure it factors. In fact, not only should it factor, but you should get the same expression twice. In this case, x plus 7, x plus 7. Oh my gosh! Quantity squared, look at that. Parentheses squared. As far as the y, that's just going to remain y squared. Okay, now let's pretty it up and put it in the answer. Expression squared, all right, x plus 7, quantity squared, plus, see the point is that should be comparable to this. All right, that's a little tricky, but the y squared, no big deal. That's y squared equals 18. Now let's get into this. What are the values of h and k? What are the coordinates of our center point to get things going here? Well, as discussed previously, what would x have to be for that to equal 0? -7. -7 plus 7 would be 0. What would y have to be for that to equal 0? Yeah, 0. Agreed. Now if you're like, this doesn't look like that. Okay, outside the box, thinking outside the box here, right? Couldn't you write that as y minus 0 parentheses squared? Isn't that the same thing as just plain old y squared there? Does that make you happy? Does that look like y minus k squared? But isn't it silly to put y minus 0 parentheses squared? That's just y squared, all right? So the point is, that would be 0. So we can go to that ordered pair, -7, 0, which would be right here, and that'll be the center of our circle. All right, and then how big do we make the circle? That would be the radius, and I want to remind you, you get that from that r squared that's on the other side, in this case the 18. All right, now, okay, this is maybe a little bit of a freak out moment. When you square root both sides of that in order to figure out the radius here, you go grab a calculator and you go, well, I took the square root of 18 there, and I've had this happen where somehow that'll freak somebody out and they'll go, oh no, that's a weird number there. Okay, big deal. Your radius can be an approximate number. If you round that off, I believe it's something like 4.24. Yeah, 18 is not a perfect square, therefore its square root was weird. Oh no, that can't be a radius. Why not? Okay, so anyway, the square root of 18 is approximately 4 1/4, let's call it. Yeah, radius can be a decimal. Turned out to be 1 here. So we'll go about 4.24 units from our center. So, and again, if this goes outside the grid, don't worry about it, just extend your grid, you know, go with the flow. But anyway, 4 1/4 to the left, 1, 2, 3, 4 1/4, 4 1/4 to the right, 1, 2, 3, 4 1/4, 4 1/4 up, 1, 2, 3, 4 1/4, 4 1/4 down, 1, 2, 3, 4 1/4, bang, 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 perfectly round. I missed my point, fatten it up, you know, okay, do your best, that's all I can ask, all right? But anyway, do the math. These will be 2 points apiece, so, you know, be careful, make sure you get the details right. But that's basically the best I can do for you when it comes to circles, and I wish you the best, and good luck to you all. Now that we've come, you know what I'm going to say, don't you? Now that we've come full circle,